we're pleased to be hosting our 30th event on building with natural materials. This is the second in our masterclass focused on retrofit. We've got some really great minds from across the industry presenting tonight, followed by a panel session where the speakers will be able to answer your questions posted in the chat box. So without further ado, I'd like to introduce Ilias Igamendes. Ilias works at Ecological Building Systems and will be here to discuss the retrofit of floors using natural materials. Hi, Ilias. We've got Adam Illes from Eco Renovation UK, who will then lead us into the retrofit of walls in relation to both internal and external wall insulation. And finally, we've got Richard Oxley from Oxley Conservation, who will discuss retrofit in relation to roofs. Before we kick off, I'm sure most of you already know about ACAN, and some are often involved in the network, but for the benefit of others in the room, I'll hand over to Aurora, who will give a really brief introduction into who we are and what we do. So over to you, Aurora.
Hello. So for everyone new to ACAN, we are an open voluntary network of individuals in the built environment industry. Formed in April 2019, it has now grown into a global network of over 3,000 people. It started with a vision for how we could work autonomously as a collective of individuals in order to make rapid decisions and respond quickly to the climate emergency. Our manifesto has three overarching aims: so decarbonize now, ecological regeneration, and cultural transformation. You can read a little bit more in detail about these here and on the ACAN website. ACAN is made up of many groups, including these 9 thematic groups, of which natural materials is one. Each group is made up of individuals who want to make change happen, and a couple of people from each group take a coordination role to help facilitate the group and any actions. You can hear more about what else is going on in the other groups by joining ACAN, and we will share a link to the other groups in the chat box. I'll now hand back to Steph to introduce the other speakers.
Thanks, Aurora. So we've got an absolutely fantastic turnout today, and I have to say, we don't normally use our mute buttons quite as much because there's not so many people. So thank you everyone for showing up. So first speaker of the night, Ilias Igamendes from Ecological Building Systems. I'm going to hand over to you, Ilias. Thank you.
Okay, thank you all for joining the session today. Yeah, I'll just jump in straight away because I know time is precious for everybody and it's a tight program. So yeah, so my name is Ilias Igamendes. I work as a technical support engineer at Ecological Building Systems for the last 7 years. I'm a civil engineer since 1998 and a certified passive house designer since 2012. Also a retrofit coordinator. I have quite a bit of experience in design and construction, especially in low energy buildings for the last 10 years. So today I'm going to talk about how to thermally upgrade existing floors in traditional buildings. So yeah, the aim of the presentation is to outline a few methods of insulating ground floors with natural diffusion vapor open materials. So that's going to be suspended timber floors, insulating from above or from below, and moving on to the solid floor refurbishment with an insulated screed and glass foam aggregates. So it's estimated that there are about 10 million suspended timber floors in the UK. Typically, suspended floors are responsible for around 35% of the heat loss through the fabric of the building. And just for context, walls are responsible for about 35% of heat losses, the roofs about 25%, and the windows and doors and openings around 25%. So this image is showing the typical construction of a suspended timber floor prior to the upgrade. You can see a good separation between the floor joists and the ground below. This is basically for 2 reasons. The first is that this prevents the timber joists from coming into contact with the ground moisture. And the second one is that the space below the joists enables the void to be ventilated. And by ventilating the void, this achieves moisture regulation or humidity regulation on that crawl space. And this is achieved via air bricks. So the ground below could be either just soil or concrete slab, for example. And if the ground is particularly damp, then you could also you have the option to lay down a damp-proof membrane to eliminate or reduce the humidity that's coming upwards. So you have to assess every time whether the existing floor is suitable for applying one of the solutions I'm gonna discuss today. You have to check for moisture, you have to check for infestation or rot or any degradation of the timber, because you may come across these types of pictures, and of course in this case probably that's not so straightforward, and probably these solutions wouldn't be suitable. So the first thing I'm going to say about the suspended timber floors is how to insulate from above by removing the floor coverings. So this methodology incorporates three main aspects. That's the natural fibrous insulation, which is diffusion open, what we call breathable, and also two types of membranes, a draft-proof membrane, which is an airtight but vapor open membrane, and the moisture control membrane, which is an airtight but vapor closed membrane, and I will explain. So basically that's the system we suggest from above. Well, starting from below, it's the soil, and then the well-ventilated crawl space, and then above that, what we do is that we drape the blue membrane up and over in between the span of the joists, and create like a cradle for the insulation. So we pin the blue membrane on the side of the joists, and there are four purposes basically for this membrane. The first is to eliminate the thermal bypass. You can see that the membrane is actually sealed on the overlaps, and also it's sealed on the perimeter. So it's very, very well sealed, and it's isolating the air from the below to above. So there is no chance that the air gets into the insulating zone, because if air gets into the insulating zone, then the performance of the insulation is significantly reduced because of thermal loops, convective loops. So that's the first. The second is this membrane provides a draft proofing across the full surface of the floor, so no cold air from below passes through the membrane or from any gaps into the warm space above, into the rooms. The third is that, as I said, it creates like a supporting substrate for the insulation. And the fourth is that being vapor open, it helps everything to stay dry. So it has the capacity to allow the moisture to pass through and be ventilated out through the well-ventilated crawl space. So once we've done this, we friction fit the fibrous insulation in between the joists. This is usually hemp jute insulation, or you can use even fiber, flexible wool fiber. We want the mats to be flexible to fulfill any gaps. And then on the top of that, across the top of the joists, we install the green membrane, which is a Proclima, it's called Proclima DA membrane. That's a vapor control membrane, which is also airtight. As you can see here, it's also taped on the overlaps and sealed on the perimeter, either with a mastic or a tape. So we have a fully enclosed envelope there that performs well from the thermal point of view as well as the moisture point of view, because this membrane, being vapor control membrane, won't allow any moisture to pass through from above, from the vapor that is in the room towards the insulating zone. So that's the system from above. Now we tend to avoid using rigid insulation because rigid insulation allows for gaps and won't be fitted perfectly in between the joists. So all these gaps allow for the air movement, and the air movement, as I said, creates thermal bypass, convective loops, and that significantly degrades the performance of the insulation, as well as it increases the moisture risk. So yeah, we go for flexible insulation. And here is an example of that methodology being applied in real life. You can see how the membrane is installed, pinned with supporting batting on the side of the joists. fully sealed on the overlaps and the perimeter, then full filled with the fibrous natural insulation, hemp jute, again in this case, and then on the top sealed with the membrane, with the vapor control membrane. Again, the membrane is taped on the overlaps and the perimeter. This system can accommodate underfloor heating, either aluminum trays or a pre-routed board, so that sits on the top of the joists in both cases. And just to give you an indication of the U values for a typical 100 millimeter deep joist floor, full filled with thermo-hem combi jute insulation, the U value is 0.26 watts per square meter per Kelvin. And that's for specific PA ratio and area, but yeah, just to give you a rough indication of the figures. So that was from above. Now there are cases where either we want to avoid internal disruption, or it's impossible to remove the floor coverings or the floorboards, and we want to insulate. The only option is to insulate from below. Of course, that requires enough space to work from below, but this gives us the opportunity to also add some more insulation under the joists. This could cut the thermal bridges of the timber and also increase the overall U value, reduce actually the overall U value. So that's the system from below. Again, you can see we use a membrane. Now start from the top. Instead of the green membrane, we use a membrane called Intello Plus. Again, this membrane is an airtight and the vapor control membrane. The only difference is that we cut this membrane in strips. So we pin and we seal the membrane on the sides of the timber on each span. And then, yeah, you can see that here. And then we fulfill with friction-fitted insulation, again, flexible insulation, typically hemp jute insulation. And then on the bottom, we use exactly the same membrane as previously, the blue membrane, the wind-tight and vapor open membrane called Solitex Plus. And below that, we stabilize the membrane with using some buttons along the joists too. So that's one option. Another option is, instead of using as a finish layer the Solitex Plus membrane, the blue membrane, we can use a tone and grooved wood fiber board that interlocks on the bottom of the joists. And as I said, this way we reduce, so we improve the U value slightly more, and we also cut the thermal bridges of the timber. And again, just to give you an indication, previously we were talking about the U value of 0.26, but by adding 60 millimeter wood fiber board underneath the joist, that improves down to 0.18. And of course, the floors, when we take up the floorboards, yeah, in some cases we meet ugly stuff in there, or in most of the cases. And yeah, probably we won't be able to tape properly, for example, the perimeter and everything. I mean, theoretically, everything is fine and easy, but in reality, this may be difficult. So instead of using a tape, for example, for taping or a mastic, we have another product we suggest. It's called Aerosana Viscon. That is a very flexible liquid applied air barrier. Basically, you can either spray it from a distance or from close. So whenever you don't have access or the substrate is not suitable for taping, you can use the Aerosana, and that's a great option for air sealing around different ugly details. There is a very comprehensive installation guide on our website. You can download it from that link, going step by step, you know, how to insulate either from above or from below, those two options for suspended timber floors. Also, I have I've sent to Barry the link, and she can probably include it to your party bag. So That was for suspended timber floors. Now, moving on to the solid floors. You probably come across that's a very typical system of for insulating the floors, dig down, fulfill with gravel, kind of like glass foam aggregates, which is very good insulator, and then laying on the top a lime based screed. So from the bottom to top, it's the soil, then a separating geotextile membrane, then the glass foam aggregates, then another layer of the membrane, and then the lime-based screed on the top. Now you can find that system with just lime screed, or we suggest using a diathonite screed, which is a lime and cork based screed with a very good lambda value, thermal conductivity. So in this case, you can see the standard cement screed has a thermal conductivity of 0.4, the lime screed or a hem screed 0.08, whereas the diathonite screed has, actually there are two variations, one with 0.047 and another one with 0.060 watts per meter per Kelvin thermal conductivity. And I have a comparison chart here showing how you can improve further the U value by using 50 millimeters of the screed, the diathonite screed, instead of like a normal lime screed, for example, or 75 millimeters of diathonite, and so on. So if you are tight in space, then diathonite screed may be very beneficial. Because the glass foam aggregates, if you have enough space, you can fulfill, I don't know, 500 or 600 millimeter thickness of glass foam, and glass foam is great insulator too, so this may do the job. But there are cases where the space is very limited, and you can only apply, I don't know, maybe 110, 120 millimeters of glass foam. Then in this case, especially using the diathonite screed over the top of the glass foam aggregates could prove very beneficial. Yeah, and you can see here how the glass foam aggregates are wrapped in between those two membranes, and then the screed can be laid on the top, and that's the final finish. And on the top, you can apply either tiles or timber floorboards, or even just the carpet. Or in some cases, I've seen people polishing that screed. And yeah, in terms of the installation, the screed can be either hand applied, mixed first in a cement mixer, then lay down the reference bands, fulfill in between the reference bands, and then smoothen with the straight edge. Or much quicker application is by using a plastering machine and yeah, pouring the diathonite screed over the glass foam aggregates and the membrane. Just quickly show you here how easy installation, quick installation that is. That was yeah, application above the glass foam aggregates. However, you can also use the diathonite screed above an existing slab, as long as the slab is in a good condition without having any water ingress from the bottom, for example. You can use that, or you can tank, and that's what we usually suggest with use a damp-proof slurry coating on the top of the slab to make sure there is no ground source damp coming into diathonite, and lay over the diathonite screed. You can embed water pipes in it. Just have to make sure you cover with at least 30 millimeters of a screed above that. And yeah, in some cases you may need to use an embedded mesh. In terms of underfloor heating, you cannot embed underfloor heating within the diathonite because that's insulating, so it won't distribute the heat basically. So if you want to use underfloor heating, that needs to be above the screed. above the diathanite screed. And yeah, basically that's just two pictures from a project we've done with diathanite screed. And yeah, you can download both installation guides from a website, or as I said, Vary can share that with you. I made sure I put that in our shared folder, Vary. So yeah, that's that basically. I don't know how well it went, and am I beyond 15 minutes?
No, you're very perfect. So thank you very much, Ilias. That was really, really interesting. And I didn't know much about diathanite screed at all. So I'll definitely kind of look into that in the future. So thank you. Okay, on to our next speaker. We have got Adam Ilias, who will be talking you through the retrofitting of your walls. So over to you, Adam. Thank you.
Thank you very much. Let me just try to share my screen. Yeah, so thank you very much for the invitation. My name is Adam Ilias, and I run this company called EcoRenovation UK. This is a construction company, so you will see a lot of construction pictures, not so nice as from Ilias, but definitely live ones with the messy construction sites. What we are doing is mainly listed property renovations and traditional buildings. We do extensions, loft conversions, and insulation works. And we also have a consultancy service when we are advising on insulations for traditional buildings. Usually through the consultancy, the main questions that come up from clients are the ones which I would like to show you, and we will speak that through. Firstly, the clients usually ask, shall we go for external or internal wall insulation, which is a valid question. The second one is usually, which is the system that we should use? What's the best material and method? And the third one, which we always think about before we start any work, are the details, which is always difficult and which we always have to sort out up front. And we always find newer and newer methods and surprises which we have to sort out. So that's really important. What I will go through now is a question on the external or internal wall insulation, but I won't show pictures on that because of we've got a really tight schedule, but I will show you pictures on the other parts. So the rule of thumb is really that we use external wall insulation if possible, because it's just less risky. It's less risk of condensation, moisture ingress, less risk of thermal bridging, and we can keep the thermal mass within the thermal envelope, which is important. But of course, there are sometimes other considerations that you want to keep the building's appearance. You've got architectural ornament in the front, obviously that needs to be kept, or it has to be because it's a listed building and you can't really touch the external side of the building. Then obviously you have no other choice than insulate internally. Also, consideration can be if you have got other works in the property, because if you have maybe an extension to put on and you've got a rear elevation there, it's really logical that you would put external insulation next to it. Whereas if you have an internal, you're gutting out the whole house internally, sometimes it's just easier to do an internal renovation, an internal wall insulation. Sometimes, of course, you can have so complex external surfaces that you won't go for external insulation in that case. Or access can be a consideration. Sometimes you just don't have access to an external wall or the external face of the wall, and you have to do the insulation internally. Obviously, there are some other considerations, but these are the main ones. Okay, so the second one is a bit more interesting. Which material and method to use? The main considerations are really that first one is U value. Sometimes you have to or you want to achieve a certain U value or some level of insulation, which with some products it would be a little bit more difficult, or it would take more space to reach the same U value. Or another consideration is the finish, and this is typically relates to the external wall insulation. If you have a render on the external side or a cladding, or you want to keep brick slips or the visual of the brick, they will all define or rule out some insulations. Again, conservation and listed buildings can define what material you will use, because some of them will be accepted and some will be not accepted. Dampness is an interesting one. So obviously you have to always deal with dampness before you put any insulation in. That's important. But there are some areas where the dampness will define what you can use, or there are, let's put it that way, there are materials which are a bit more forgiving if you've got a damp area rather than others. Wall conditions, that's mainly, I meant here, wall problems, levels, bad brickwork. These will be all things which might define what you will choose as a material. And obviously cost is a consideration as well. Now, let's go and see a couple of projects. This is a brand new one. We are just in the finishing of this. The architects were Green Architecture. It's an internal wall insulation, and they defined wood fiber board here to these elements. And the reason behind it, which is shown on the right-hand side picture, is that that works really well with the same wood fiber elements which are on the roof. You can you could do that with an external wall insulation as well, but it would be just difficult because there's a parapet wall and there's a green roof over the top. So that is a very ideal scenario that they've chosen an internal wall insulation together with the roof insulation. You can use the same lime plaster everywhere. It was a good choice. This is another product I just wanted to show you. I've used that a few times, not very often. It's a calcium silicate board. It's a natural material, but it's not organic as cork or straw or wood fiber. So they usually, we usually used it in areas with high condensation risk. Again, I want to highlight here that condensation is something that you have to deal with first. So the ventilation needs to be sorted. But still, if you see a wall, for example, which is absolutely cool, this one, for example, on the left-hand side, that was a single brickwork wall, and it was covered with mold, really, with a cement render on it. Obviously, it'd be good to use something which is a bit better against condensate risk. And the calcium silicate board is absolutely perfect for this. The workability of the product is brilliant. It has got in the system a thin lime coat plaster, which you can just apply on the top, and it is paintable. It's a good product. Now, sorry for the blue light. It's because we had on the site a blue tarpaulin over the extension. This is one of my favorites. This is hempcrete, and the hempcrete is hemp and lime mixed together, and we use it for new build and extensions, really. It can be used for internal wall insulation. It's just rare because it needs space. For example, this wall is about 220 millimeter wide. And you cannot use, for example, hempcrete where you've got not more than 40, 50 millimeter. I think maybe about 80 to 100 from about 80 to 100 millimeter, you can start using it. But the consideration here was very straightforward, because we built the extension out of hempcrete, and it works really well with moisture. It manages the internal moisture really well. It has got a thermal mass, unlike the other insulation products. So it was very straightforward that if I build that wall at the back, which you see those dots, which are the extension wall fixed to the timber frame, the extension, the hempcrete of the extension is fixed to the timber frame, that it was really straightforward that on the side, I would use the same material, the hempcrete, for insulating the existing wall. Let's get to my other favorite. This is a lime cork render. It's called Diathanite Evolution, which I use for like 5 years now. This wall that you see in the middle, it's a gable wall of a Victorian property, mid-Victorian property, and there were quite a lot of problems there. That render has been, that's a cement render, and there was a lot of dampness in it, lots of cracks. So I assume that the brickwork conditions will be really bad behind it if I take it back. Obviously, because there were dampness as well, I had to remove the cement render, no question. I have to do that every time in that scenario. And when we removed it, that was the brickwork we found behind it. It was just horrendous. It was just horrible. Now, imagine if I had to use a board product here, what sort of preparation I needed to do. It's like patching up, then at least 2 layers for just leveling, at least 3 coats of lime work, really, before I can start any sort of insulation. Instead, I used the lime cork insulating render, the diathanite, with a spraying machine, and it's just beautiful. I mean, I see that beautiful, that, you know, all these holes which were horrendous in the brickwork, you know, we just changed them to you know, thermally efficient little spaces, and we built it up to 50 millimeter. And after that, you build it up on the left-hand side, you see that you smooth the render out, the base coat, then you put a lime coat over it, or a vapor permeable render, and then that's what it will show it. So you don't see that. That's a wet product, but after that it has been finished, you don't see the difference, you know, between that or another kind of board insulation product. Okay, so that's a little bit of a detail. Sorry about that. It's a bit ugly detail, but I wanted to show you because the consideration were here dampness. That was an internal wall insulation in London. The architect, Pruitt Bisley Architects, they designed the same diathanite plaster here, but this house was damp on that side of the wall. The whole wall, it's just one section of it, and there is a chimney and then another room, and that wall was totally damp. They took back the cement render, so the dampness started evaporating, but I wouldn't be brave enough here for maybe using a wood fiber insulation, for example, especially because on the outside of that wall, that was a road which they couldn't touch, and all the water actually got you know, flowed towards the wall, and they couldn't really do anything with that. So the architect designed the diathanite insulation in, but before we applied the thermal insulation, we used a specific base coat to it, which is a salt inhibitor base coat that's called the diathanite regularization plaster. Just to the, I don't know, up to 600 millimeter or so, as you see that on the picture. And then we went with the diathanite lime and cork plaster over, finish it up, as you see on the right bottom picture. It could be finished well. So that's what I meant by that the dampness also can define what material you use, because there are others, as I said, I wouldn't really use a wood fiber here. I'm quite brave, but I wouldn't be brave enough for that. This project in North London, that's an internal wall insulation, and the consideration of using diathanite thermactive, that's from the diathanite family. It's the one which has a much better lambda value, or better lambda value, let's put it that way. Actually, I don't even know any other material which is natural and has got that good lambda value, 0.037. And the idea here was that the client wanted to go for an NFIT level, so high insulation levels they needed. And we used the diathanite thermactive 40 millimeter all around in the house, including side walls, party walls, everything, front and rear. Plus, we've put 60 millimeter of wood fiber insulation. So I took a photo of the section here, which you see on the side, just to show that sometimes materials also can be mixed together in this way, that you use one and you use something over the other. I think it's an optimal mix, because the diathanite, if I use that in 100 mil, which I could do, or I could have done, but the drying time would be quite a lot. Whereas with the 40 mil, the drying time is still good, and 60 millimeter of wood fiber insulation is working just well over the top. This is a close-up of a Tudor building from 1625, where the exposed timber work has brick infill panels between with lime plaster, and the conservation officer didn't allow to put any insulation over the top, although planning accepted 50 millimeter of wood fiber board over the top. But imagine if I put 50 millimeter over the top of this, the protrusion would be just lethal to that, you know, listed building. Obviously, the conservation officer didn't accept that at the end. And we just recommended to use the diathanite plaster, because with the diathanite, I can do 10 mil, 20 mil, 30 mil, whatever it is required to achieve the surface that we want to. So that's what we've done. And visually, nothing has changed. So you see all those panels between the timber framing. This is an external wall. You see where the windows are. They are all insulated with a little bit of diathanite insulation. And that's a very good example where I can use external and internal wall insulation as well, which we haven't done externally, unfortunately, or not yet, because that was not part of the contract, the external works. But the conservation officer accepted that we could use the same material externally and internally, so that we can achieve a little bit better thermal performance on a listed building from the 16th, 17th century. Okay, now this is a totally different method, and I've used that only once. I would really like to use that again, although the insulation was here mineral wool, which I really wanted to change to wood fiber because it would work really well, but the client just wanted to use the mineral wool. But the method was that the architect, Mike Tuck Studio, they designed I-beams, timber I-joist here, because the insulation level was 220 millimeter, which is quite a deep insulation for an external wall insulation. It's very unusual. Now with this 220, the idea was that they wanted to have a cladding first, but then they changed it to a large shingle. Then obviously, if you put timber studding in, you can fill it with insulation and then board it over, or use the shingle or cladding or whatever. I have just seen one question here in the chat when Ilias had his presentation on. Someone asked about the straw board. Now, that's the only thing why I wanted to mention this, that I've seen that working in Europe with straw bale, because 220, 250 mil of I-joist is just wide enough so that you can pack some straw bales in. And I'm just exploring that now. How can we use loose straw or straw bales with the same system? It would be really nice and obviously very low embodied carbon. That's how it went at the end. So you see on the left-hand side, the insulation put in between the joist system. And then on that small top picture that shows the membrane and the counterbatten ventilation battening, And then the large shingle, which is really nice, to be honest, at the end. All right, let's get into the details. Well, I've got a few examples. Obviously, there are always more and more, but I put a list together for you so that if you are about to do an EWI or IWI, these are the ones which you definitely need to have a look at and check before the installation starts, but there are some other considerations as well. So at external walls, obviously eaves, fascia boards, window reveals, what do you do with at the ground level, plumbing and electrics and rainwater goods? These are always a question when you do an external wall insulation. With the internal wall insulation, windows, floor and ceiling junctions, interim floors, electrical fixings to wall, and obviously you have to take care of dampness or check that when you do an internal wall insulation. So I just show you a couple of details how we sort it. So the one which I just showed, the large cladding. Imagine that all these bits which I just which I've got on the list, like all the rainwater goods, gutters, gable ends, eaves, everything has been sorted very clearly with covering everything. It is a secret gutter here. On the large picture, you see that gutter. It is behind the rain screen. There is no problem with the verge trim on the other side. You don't see any downpipe, gutters, pretty much anything. That's what you see from below. It's a nice and sleek design hiding everything. I think this is a brilliant solution, and you can do that only if you've got a large amount of space there filled with insulation. You cannot do that with like 50 or 100 million insulation, because you know you can't hide a 70 mil pipe into that. But this one just hid pretty much everything. Okay, this is a project where I've used, again, diatonite evolution for this small bay, as you see. And the detail what I want to show you is the windowsill, because there are always problems with the windows, that's no question. Window fittings and the sills and heads and jambs reveal is always a problematic part. Now here the client wanted to keep that chunky, large, originally Victorian windowsills. And normally what you do is that you insulate the whole reveal and then you put maybe like a thin layer of sill over the top. But she wanted that chunky one. So what we found out is that what we will be doing is that we took back the whole sill, which was actually brickwork rendered. So that wasn't even original stone, that was brickwork and some render over the top. And we cut everything out, we prepared the reveal, that's what you see on the left-hand side picture. Then we put the airtightness tape on so that we can make that junction of the window frame and reveal airtight. And we cut a UPVC, sorry, not UPVC, an XPS insulation board out to the same shape and fitted it. That's not my invention actually, but I've seen that on a, there's a company in Ireland who are selling sills. It's called passive sills or something like that. And I've seen that that's round about what they are doing. But obviously that was a long time. We just couldn't buy it in time. So we just made it ourselves. So once the window sill has been fitted, I could then insulate the reveal with the diatonite evolution plaster. And then everything has been just, the window sill has been rendered with a waterproof render and then painted over. And then that's how it looks now, just like the original one, but there is no thermal gap, there is no airtightness problem behind it. Oh, geez, that's a problem every time when you take up a window and you want to do an internal wall insulation. That's just one of those. Last week, we opened that up and we wanted to, we will insulate it with diathanite internal wall insulation. So we had to sort out that gap with the expanding foam and the large gap next to the brickwork. As you see that, we have to somehow fill everything in and fit everything nice and tidy. So what we've done, we've just filled the hole with the diathanite evolution, which is just an extra thermal performance on that, and we cleaned that expanding foam, and we could then tape it together with the contact or solido tape, which is a plasterable airtightness tape. And next week, the insulation internally will go over that, meeting the window frame. Internal wall insulation, a problem always what you will do with the electrical boxes, because the level will change. If you put like maybe 50 mil or 100 mil insulation, all the electrical boxes needs to move further in. But the problem is that if you just put a timber behind, or you just double the frame, that box or whatever, then you will have a thermal gap behind it. So I found the ultimate solution for that, which is the Bozig board. That board is an insulated but structural board. You just cut it, you just fix it to the wall, and you can fix the electrical box on the face so that it meets your new level. That black thing is that you see behind it is the liquid airtightness membrane, which you've seen on Ilya's presentation as well. It's for the airtightness. Interim floor structures, very important when you do an internal wall insulation. It's not from floor to ceiling. It's beyond the ceiling and beyond the floor, because that's how you can meet the other insulations. And that's how you won't leave a thermal gap. So on the left-hand picture, you see, again, an airtightness membrane, liquid applied there. And on the other parts, you see how I prepared and taped the as a preparation for the internal wall insulation to make the structure airtight before spraying. And then we sprayed the diathanite evolution. That's how it looks like during the work. So you get the sprayer and you go line by line until you just finish up with the new level. And two small examples, lastly, for floor and wall junctions, which is again critical. So on this project, we have done an internal wall insulation and floor insulation together, and the suspended floor insulation somehow needs to meet the wall insulation. That's the therapy. That's what we should somehow achieve. Now, what we've done, you can see that on the top picture, that the insulation, which is the lime cork render, comes down to the bottom of, till the bottom of the floor level, so that it can meet then the floor insulation. And once the floor insulation has the airtightness membrane over the top, then that's how you actually tape it. That's the last picture, as you tape the airtightness membrane, which is above the floor insulation and next to the wall insulation. And the last picture, this is showing another problem which always needs to be sorted. That's the subfloor ventilation. The problem is usually that the floor ventilation grills are in a higher level. They are not in the subfloor level, but they are in the floor level. Now, if I insulate the floor, obviously, then I will block the ventilation, which I can't do. So in that case, you have to somehow prepare the surface and that hole, and then use a telescopic vent or some sort of ventilation channel so that you can channel the ventilation down into the subfloor. That's how it looks like. So yeah, thank you very much for your attention. How was I time-wise? Was that okay?
That was great, Adam. You were a little bit long, but I didn't want to stop you because it was incredibly interesting. So thank you very much. No, thank you, Adam. Okay, I'm going to hand over to Richard Oxley from Oxley Conservation, who's going to talk about roofs. Thanks, Richard.
Thank you very much. Good evening, everyone. Okay, good evening, everyone. My name's Richard. Historic building consultancy based in Henley-on-Thames since 1997. And I usually encounter retrofit when we take the opportunity of repair to improve the thermal performance of the building. So today we're looking at, or this evening, roofs without removing the coverings. Let me hold on. There we go. It's easy to retrofit and achieve the efficient and effective detailing by removing the roof coverings, and that's because you can get at every nook and cranny and all the junctions, just as Ilyas and Adam have shown. The junctions and the detailing are very important and the most difficult ones to address, and that's the same between different roofs, different types of roofs, gables, valleys, everything. So roofs are very complex structures in their own right. And I'm just going to show you some examples of where we've removed the roof coverings, just to sort of like give you an X-ray vision of some of the details you'll have to overcome or take into consideration if you want to leave the roof coverings intact or have to. This is a grade 2 listed building, and you've seen from the underside, it has been stripped and recovered and provided with insulation bats between the rafters and a sarking insulation board over the top. We've also used an insulation board, wood fibre insulation board from the underside where the plaster didn't get removed, and that's because it's sort of increasing the depth of the thermal mass for the building, which is a large benefit. Because we're trying to stop heat loss and heat gain, which is obviously becoming more a consideration. And that's before on the left and after on the right, and then the refurbished room internally. The next one is a grade 1 listed building where the roof needed recovering, and just showing you really, this is looking at the dormer details. So there's the roof, the slates, Westmoreland slates were starting to deteriorate, and it's grade 1 listed, and we had to take into consideration some of the constraints of that listing, trying not to change the appearance. So this will come in useful later on when we look at internally, but it just shows you some of the constraints and potential solutions. There's the roof strip back. And you can see that there's lots of junctions and detailing to take in. And therefore, we're starting to build up with a wood fibre insulation back underneath a T&G board. And this again provides good thermal mass. From the underside, we had to put roofing battens on the underside of the rafters to hold the insulation in place. And here's a build-up journey of the removing the 1-inch thick 1960s insulation on the far left-hand side over here, and then building it up in between here to get some depth in. Then here comes the detailing. So we've seen loads of tape used, and it is a good way of providing an airtight seal at the junctions, and the junctions are very important. And this building here, if you can see this, we're trying to minimize the increase of depth. So all we're going to be doing is increasing the actual depth of that insulation by 2 inches. Does it meet high performance standards? No, but we were working with constraints and doing the best we could in the circumstances. And what we will find when we're doing internal retrofit is that there are many instances of this where this example is inverted. And there's a finished detail where it looks. You'd have to have a knowing eye at very close proximity to be able to identify that. So there's the finished product. Other opportunities, this is a structural repair where there was roof spread and we had to put steels in, and then that gives you basically a carte blanche to put effectively a modern roof over the top, fully insulated. Another example is where the roof and the historic frame needed repair. There were structural issues. This dormer got changed from a flat roof dormer to a pitched hip dormer. And again, the gradual build-up of the insulation layers and the cladding, and then being dressed in lead. So, and trying to keep also the depth of the cheeks here at the side of the window quite thin, so it didn't become too fat. So the attention is in the detail, and that can influence the materials you want to use. So I'm just looking at my notes here, so bear with me, go back again. All right, so now we've looked at stripping the roof. So what are the reasons why we can't strip the roof? Well, one would be, say if you're buying a new building and the roof is in good order and it's got another 30 years left, you don't want to spend, 20, 50, 60,000, whatever it is, on stripping and recovering the roof. You may have access constraints, so it's difficult to get access to the roof, and the scaffolding costs alone may be prohibitive. And so cost comes into it. Money is going to be an issue. Levels of disruption in terms of neighbours, the street or whatever, and the physical limitations, which I'll show later with different types of terrace housing. As already mentioned, listed buildings, you need listed building consent for a change of appearance. You can get listed building consent for a change of appearance. It's never always a no. And there are possibilities of doing that, but you'd have to work to try and minimize that change. So this is a case study, which is a new one for me, where we're not looking to strip the roof, just light overhaul, and it is an attic room, effectively 1.5 stories, and with dormers in practically every room. So everyone knows or should be familiar with the warm and cold roof concept, and we're really going into a hybrid roof here, where we've got a cold roof in the attic space, and then we've got sloping ceilings. This is taken from the Historic England insulating pitch roofs and energy efficiency in historic building series, which is a good resource. So we're dealing with this hybrid, and this is sort of the within this Historic England guidance, sort of how to insulate, only gaining access from below, where you're keeping the roof, possibly the roofing felt if it's present, and building up insulation layers below. And as you can see, there's no way that this is going to meet building regulations or energy performance requirements compared to a new building, but any improvement is beneficial. And here's some examples from a website just showing you their options for fitting from the underside, internally fitted insulation. And the big difference really is the gaps there and utilising the underside of the rafters. So the big thing to deal with existing buildings and retrofit is every building is different. And so basically you have to come up with bespoke solutions most of the time to address different eaves details, different junction details. And so you've got chimneys, you've got a dormer up here, there'd be valleys down here and such like. So another consideration is in this one where you have upstand party walls, and that would actually allow possibly insulation over the rafters. So coming from above, you could strip that roof, but then you'd have to take into consideration this rainwater goods here. So how's that detail between the neighbours if you do that? Probably very difficult, and you're probably looking at internal retrofit. This one, you'd need the whole terrace to be stripped and recovered at the same time. Otherwise, you've got a difficult junction on the party wall lines. So really, we're looking at internal retrofit as an option. These are in the same street, in the same terrace, in the same age, and probably by the same builder. And just look at the difference in the two gables. One's brick and one's timber in terms of the verge detailing. And then you've got central valley gutters and then valley gutters there. So the attention to detail on these, and also if you're writing a specification in a streetscape scheme, would be you'd have to have a specification for probably 3 or 4 different types of roof detailing there at least. And same again, same street, different problems. So we can't rely on single instant fix solutions. So we're basically looking at trying to overcome unique challenges in every case. And so really it's looking at each building with a blank piece of paper and looking at your template of options and seeing which fits best. So one thing that we need to look at is how the building is currently used and how will it be used, because that will impact greatly on the insulation required and its detailing, and also possibly support mechanisms like ventilation systems. So we have to do some black box thinking, which is basically carrying out not a post-mortem after it's gone wrong, but a pre-mortem and trying to guess when, or not guess, we'll try and work out what could go wrong and how do we overcome those problems. So why do we want to insulate the roof? Well, it's bringing back a space into active use, or for the first time, or improving thermal performance. As we mentioned, heat loss and heat gain. So we're looking for thermal mass and improve comfort levels. So what is comfort? Well, warmth and relatively comfortable humidity levels. And then we're also looking for energy efficiency in terms of reducing consumption, but also managing costs. So all those will probably be high on the list, and can we be successful in doing that? Let's go back to the case study building, just to use as sort of like looking at hotspots and everything that we can consider. So if we had access up here to, say, decorate or repair the building, would we be able to perhaps strip the cheeks off the dormers and reface them so we can just get a improved insulation detail there? Because internally, as we'll see, it is quite difficult. So this is in the attic space, so in the cold space of the roof. You can see on the left-hand side here, we've got an impervious roofing felt. You could cut it out, but then you haven't got a secondary barrier, and there's issues with the life expectancy of that. So the considerations of you've got something that will be very susceptible to having condensation on the underside, but we've also got to maintain an air pathway to get ventilation into the attic space. So we've got the air pathway coming through here, so we've got to make sure that any insulation in this space does not block that air pathway, and it is maintained there, and that can be usually gained by buying some off-the-shelf ventilating detailing there. So that's a difficult consideration, because also here this is a very thin rafter, so it's about 3 inches, 4 inches, which is about 75 mil in new money, and so that then limits the amount of insulation we can actually get down into that sloping ceiling. And how do we do it? So that is a difficult area. If you look at the number of junctions and issues, so we've got all the issues with the flat ceiling here, the sloping ceiling, can we get insulation in there? Or do we say, we go back and we say, we can't get insulation in there that will be effective. Can we provide insulation boarding on to the underside? Which is probably the best solution in that instance. But then we've got an issue here. If it's a listed building, can we conceal that purlin there, which is partially exposed? Do you want to retain it? But if you do, you're causing some gaps and difficult to detail areas where you're probably going to get air infiltration and therefore drafts and everything that comes with that. Here is the junction between the cheek of the dormer, so here, and the window, and you can see that there's very little space there that we can actually get the insulation in. So that may mean that this internal face, so it's the inverted solution that we did with the grade 1 listed building, is remove the internal face and then put the insulation build up from that side. But then you've got different issues then with vapor checks and membranes. How do you detail them? So that's very difficult. And again, the solutions are difficult, and you've got to consider how to minimize those risks. So that's what we're dealing with, this cold space, which has got to be ventilated, and basically a warm box there that we want as airtight as possible. So this is a typical sort of London terrace with a dormer construction, and showing the blue areas which are potential cold bridges, and then the circled areas are difficult areas to insulate without stripping the roof or building up internally. So when we're building these things, what are the design considerations? Well, are we preventing heat loss or reducing it? And we've got to be realistic and say that we're not going to achieve modern day standards, because we can chase different sort of measures of either heat loss U values or whatever you want to use. But at the end of the day, we might not be able to achieve it, but some gain is better than nothing. We've got decremental delay, which is important, especially if you're in an attic space, because in the summer that could be very uncomfortable. And so what we're looking at is trying to achieve a 12-hour delay to prevent the heat penetrating the roof, and then it cools down in the evening. Again, may not be achievable, but something's better than nothing. Air tightness, if you're using a new roofing felt, you've got to make sure it's bat friendly if there's bats going to be present, or but also we're looking at tapes and various ways of making the building improved airtight. And you've seen the spray on plasters and renders, which could be very good, because that's a good way of making a building airtight, is applying a render or a plaster. So that's another way of doing that. Vapor permeability, ability to dry out. This is quite important because wet fabric has a poor thermal performance compared to dry fabric. So if your building fabric is able to dry out and doesn't hold moisture, that's good. And then there's a balance of the hygroscopic vapor permeable materials like wood fiber, which we're going to be using or advocating in this case, because it has those very qualities. So it needs to be able to dry out as well. So we're, oh, sorry about that. I didn't realize I could do that. So the existing fabric, we've got conflicts, and some of these have already been mentioned by both Ilias and Adam, is where we've got a conflict between putting in perhaps a vapor permeable, breathable system against impermeable materials. I noticed on the chat that someone was asking how to do that, and Ilias sort of mentioned something as a solution. And so we've got to look at are the materials compatible, and what are the benefits? We've got to be aware of the dangers of reduced ventilation pathways. And also we've got to be aware that internal insulation was probably going to reduce the internal space available by making intrusions into the walls. And that may affect internal joinery such as skirtings, architraves and such like. So there are limitations in the improvement you can achieve. But what we can do is make what insulation we do put in robust, and maximizing what we do put in by focusing on the junctions and the detailing with that. We talked about the listed building status and the constraints that can have And any alterations in a listed building internally or externally require listed building consent if it affects the appearance or the character of the building, mainly the character of the building, which is open to debate. So if you're replacing, for example, lard and plaster ceilings with a wood fibre ceiling or any other type of ceiling, plasterboard, that would require listed building consent. Compatibility and performance is very much so, especially with the old historic buildings, because what we're trying to do is maintain a breathability wherever possible. And a big factor that we can help the building is removing moisture at source, so extraction fans, and maintaining means of providing ventilation, so warming air, cooling air, and also getting rid of purging, basically, high humidity levels. Why have we chosen, or why have I chosen wood fibre insulation? I think basically I've been using it for too long, really. But in terms of I'm comfortable with it. I don't have a vested interest in it or anything. It's a material that has good characteristics that are compatible with all materials. It's very forgiving. It also acts as a very good thermal and moisture buffer, so it can reduce thermal shock and moisture shock, so reducing risks of condensation and therefore mold growth, which is good for the building and the occupants. So these are sort of things that we can advocate for wood fibre, and it's also a good usable material. It's easy to use in terms of cutting and fitting, and it's also relatively flexible, so you can still have undulations and things in roofs, which is aesthetically pleasing, but also it prevents additional costs in terms of furring out timbers. So I think an important consideration in all this is, how did the building perform before retrofit? Was it damp? Was it heated? Was it ventilated? And when you implement changes, how will it perform after? So really, what are the consequences of change? Because that could influence your solutions. So again, carry out a pre-mortem in terms of trying to figure out where the conflicts are and where the problems will be, and try and design them out at source if possible. Something, you know, on Adam's presentation, but where he talked about details, and it's at the junction of a roof. And so this is basically a sort of example of a pre-mortem where they've identified that there's a high risk here if you put an external insulation and there's a gap. So if you block that, then you're reducing the risks of condensation and cold bridging. But then some people don't read the guidance, as you can see here. So, so what I've come to say really is looking at a retrofit without removing the roof covering is difficult, and compromises have to be made. But I think in most cases, a lot of people don't have the opportunity or affordability of stripping the roofs. So if we're really serious about retrofitting this existing housing stock, and you've seen from the buildings that I've shown that a lot of those are, you know, need to be upgraded if you want to use the attic space. Therefore, this is a way of getting more buildings solved than actually doing a full retrofit by stripping the roof. And it may have a shorter life, but we are trying to get somewhere very fast in terms of retrofit. This is a good introduction to energy efficiency and historic buildings, but also to existing buildings. So it's good to supplement any other resources you may want to use. So that's it, Steph, over to you.
That's great. Thank you ever so much, Rich. It's really interesting. And I really like your philosophical approach of a pre-mortem. So yeah, and thank you to all the speakers for some brilliant examples and some great technical insights, because I think we've not really had an event like this before. We've dug in so deep and it's been very successful. And I think the chat box has sort of reflected that. Just to answer one of the questions that came up in the chat, we are recording this and it will go on YouTube with all of our other videos that we've hosted as part of our natural materials series. So please go and check it out and we'll post all the links at the end. So I'd like to ask, we're running a little bit over time, but we're going to do kind of 10 minutes of Q&A for anybody who'd like to stick around. And yes, I'd ask Rich and Adam and Elias kind of just to have a chat. Just first one for Elias, it was about flooring and kind of going along the practical line. Are there any other particular underfloor heating systems that you'd recommend to use with your the underfloor, sorry, the systems that you've been talking about as part of your talk?
Yeah, no, I think these two are the most common and the easiest to install. I mean, you could. I mean, we've seen cases where like a dry screed has been installed, but I think, yeah, stick with the aluminium trays or the pre-routed boards, I think.
Great. Quick fire answers, this is good. There's another question that's coming about, is there any reason not to use Hessian instead of a plastic geotextile
No,
membrane?
not really. No, you can. It's just a separating layer between the components. So no, you could use that if you want. Yes.
Okay, brilliant. And then the last one for you is about, has anyone tried replacing a suspended timber floor with a solid floor system?
Yes, actually, if the situation is ugly under the existing floor, like very damp, or if the floor is very close to the ground and there is no a chance of ventilating properly, then you'd better change that and switch into a solid floor, like either a slab and the insulated screed over the top, or if you have the or if you can dig down and use some glass foam aggregates, that's even better. Do that and use a screed above that. Glass foam aggregates act as a capillary break because they're completely inert to water, so it's a capillary break between the ground and the insulation in this case, and it's a fully breathable system. So yeah, that's a much safer thing to do.
Great, thank you. Adam, do you have any experience of insulating chimney breasts?
Oh, very good question. I've just got one now. That's a headache, isn't it? So I can tell you what I do now with the chimney breast in this project. I'm not saying that's the only solution. So imagine 2 rooms, 2 chimney breasts. One chimney breast will be in use, the other one won't be in use. So the one which won't be in use, I just go with the diatomite lime cork render all over and inside as well. Inside that small grove in the chimney breast. Obviously, in that case, because you have obviously cold air coming into the chimney breast, that's what you want to somehow reduce, right? So and obviously the bottom of the chimney breast, it has to be the upper part of the hole that needs to be also insulated with some sort of insulation board, but still may be kept ventilated. So I just found a product from Lindab, which is an aluminium ventilation grill where you can actually move the a small circle so that you can ventilate it or close and open the ventilation. That's what I've used there. The other chimney, which will be in use, that's a little bit tricky because if you insulate the whole chimney breast all around, that means that when you make your little fire so that you can have a little bit of, warmth, then it needs to come through your insulation level, which is not really nice. You just actually reduce the warmth coming from that chimney. What I'm doing, that the side of the chimney breast, I use the diatomite plaster and in the front as well, but only I use 20 millimeter. It's a silly compromise with, to be honest, with the chimney breast. I had another site where the chimney breast has not been, the chimney has not been used, and they just filled the whole chimney void with a material called Ilias, can you help me out?
Vermiculite.
Vermiculite. So they used vermiculite to just simply fill the whole void in. The it's a bit of a gray area. I'm not sure that every building control surveyor will accept that, because the idea with the chimney breasts and the chimney flues that it needs to be ventilated somehow. Now, if you fill it with whatever it's called, vermiculite or something else, it can't be ventilated. But this client of mine, he was positive that this will just go through, and that's what he wanted. He wanted a super insulated house, and we filled it with vermiculite. It worked for some time, for sure, but obviously if up to for 10 years, I don't see that. But that's certainly an interesting question.
Great, and that's a really good answer, very comprehensive, thank you. There's a question about, is there a recommendation to apply, I assume it's about diathanite, because I would say we are not diathanite salespeople, but it's an excellent, outstanding product, particularly on the kind of wall and floor insulation side. Is there a recommendation to apply this over existing plaster for insulating internally?
No, that's the short answer. If it's a lime plaster, then you can use it over, but I've never done it. And the reason being that when you take off the linings or the wallpapers, then the lime plaster behind is really not stable enough. I've never seen one which was stable enough. If the lime plaster is stable, then you can use over that. That's not a problem. But also the other consideration is that you've got maybe 15, 20, 25 millimeter of plaster on the wall, which if I replace that with diatonite thermactive, I'm pretty much halving the heat loss with that 25. Even you don't lose pretty much anything. Well, maybe not 25, but 30 mil, let's say. So that's a valuable space for something which has a thermal efficiency. So that's why I would certainly take every plaster off. If it's cement, then for sure. But if it's lime, as I said, it's not necessary, but I think it's advisable.
Yeah, brilliant. And if
also,
gypsum.
Also, gypsum has to be removed too. Just to add to Adam's.
Yeah, brilliant. And just if anyone wants to learn more about diathanite, we did have a event on about cork about 6 months ago, and we had a diathanite speaker on that. So if you want to learn more about some technical details, that's quite a good introduction. Richard, what materials are you using for the sarking board and the insulation in your products? I'm pretty sure it's wood fibre is the answer, but what are you using for your sarking board?
Plasterboard.
Your sarking board?
Oh, sarking board, wood fibre, TNG. Basically, it's our material of choice, and you can get thin, about 35 mil board, which then follows the contours of a roof, so you can maintain the character and appearance of the roof. So that's good. And then if you need more insulation, you can try and achieve that either between the rafters or the underside. Does that answer the question?
Yeah, no, that's great. And then in terms of there's kind of one that's come in, and it's a question we get all the time in natural materials, but I'll let you answer, Richard. It would be good to have a general idea of how much more breathable insulation costs compared to rigid foam.
We had a very interesting conversation with a quantity surveyor who wanted us to go down the foam and foil route rather than wood fibre. And we convinced that quantity surveyor that basically if they applied the same level of workmanship to the detailing that was necessary, there wouldn't be much difference in cost, because the labour is the more expensive cost. So if you want to compare like for like, then make sure you're dealing with a craftsman, not someone who's just going to put it on without attention to detail.
Yeah, I would 100% agree with that. I don't know if Elias and Adam, if you've got anything else to add in the pro-natural materials.
Sorry, I lost you completely. I didn't get the
That's okay.
So sorry.
I think what we're going to do is just got an eye on the time. It's 8:30. I've got a bit of a wrap up about ACAN, and then we want to leave with a kind of parting sentence or a couple of sentences from all of our speakers about retrofit and natural materials in the context of what they spoke about today. So I'll do a wrap up, and I'll leave you three just to have a quick think about that. So just so everyone's aware, We are okay. I just want to say we had an incredible turnout this evening, so thank you ever so much for everybody who came. I hope you've learned something and it's been really informative, and as I said, we will be sharing all the information again because it's quite a lot to take in on a Monday evening. I just want to wrap up by saying that we'll be continuing our series of natural material events in 2023, so please do join us as we kind of continue going through our material masterclasses and also our retrofit and myth busting sessions. So I want to thank all of our speakers once again. You've been brilliant, and if you'd like to leave us with kind of parting words, that would be brilliant. That would be ace. Thank you. I'll start with Ilias.
Yeah, so that was excellent. Thank you all for joining today. Yeah, on a Monday night. It's actually, I live in Greece, so it's even later here. So it's 10:30. So yeah, thanks all. Thank you, Adam. Thank you, Richard. Excellent presentations, and thank you all for the questions. Very interesting. If you want to reach out, yeah, just drop us an email. Yeah, if we missed any questions, yeah, just shoot us, and yeah, probably we'll get back to you as soon as possible. So thanks, everyone. Excellent, Stefan. Thank you.
Thank you, Adam.
Yeah, thank you very much for the invitation first. Secondly, I had to say that I put the presentation together and I had loads of other pictures as well. And at the end, I just showed half of it. It's not a problem, obviously. It was a very, very tight time frame. But if anyone has any problem or a particular question regarding one particular property, I'm very happy to help. So you find my email address at the bottom of the presentation. Just drop me a line with a couple of pictures and I will just try to help, because obviously from a 15-minute presentation, you can't just have everything. So I understand that. Thank you.
Thanks, Adam. Rich? Oh, you're muted. Ending on a high.
So thank you, everyone, especially Ilias and Adam and everyone for arranging this. And just as a soundbite, really, about natural materials and working with existing buildings, I find them very compatible and comfortable using them. So in terms of the performance and usability, so I think this is great work, and keep the good work up. Thank you.
Brilliant. Thank you, everyone, for coming. I'm going to end the meeting now, but yeah, we'll see you in the new year. Thank you.